First things first, what exactly is a subset? Set A is a subset of set B if every element of A is also in B. Picture it as a small box sitting completely inside a bigger box. So A fits entirely inside B. This is the notation we use. We write it as, so we read it as A is a subset of B. Okay, A is a subset of B. So this is what we are going to do here. We are going to check every element of A. If each one is in B, then we can draw the conclusion that A is a subset of B. Let's do it together. So A equals 1, 2, 3. A is 1, 2, 3. B, 1, 2, 3, 4, 5. So let's check. 1 is in A, is that in B? Yep. 2. Yep. 3. Yep. So all the elements in A can be found in the bigger element B. Therefore, A is indeed a subset of B. Now that we know what a subset is, let's look at the three symbols we use to express these relationships. Three symbols, yeah? The very first one means is a subset of or equal to, which means here equality is allowed between the sets that we are comparing. Then, second symbol here means is a proper subset of. That means every element of A is in B, but A must not equal B. And for the third sign, as you can see clearly, it means is not a subset of. Okay, at least one element of A is missing from B. The key rule to remember here is this right here allows for equality. This does not. Are you with me so far? So the distinction is so important. Okay, we're going to look at it and break it down properly here while we look at the proper subsets versus improper subset. So for a proper subset, it is when every element of A is in what? B, but the sets are not equal. B has something extra. On the other hand, improper subset is when A equals B. So all the elements here can be found in B. That is when we use the improper what? Yes, that's what we call an improper subset. So the bottom line here is this allows for equality. This requires a strict containment. Do we get that? Under no circumstance must A and B be equal. Once they are equal, then improper subset. Got it? Now,
before we continue, if you're enjoying this lesson, there's a lot more waiting for you at SageCube Academy. We have live online classes, full lesson notes, tutorial videos, WASSCE past questions, practice exercises, flashcards, and more. All in our study app. Visit sagecube.org today to register. The link is also in the description below. Now, let's get back to the lesson.
Here's a special case that surprises most students, the empty set. So the special rule is the empty set is a subset for every set A, no exceptions whatsoever. Why? Why do you think that is the case? Because the empty set has no element. There is nothing inside it. So there is no way you can fail the check. It is always going to be true. That's what we say in mathematics as rigorously true. It is always going to be true. Okay. So we see the empty set. It is part of it. It doesn't violate the rule. Do we get that? But what you have to, notice here is the empty set here is also a proper subset of any set, so long as that set is not empty. Because once that set becomes empty, then the two are equal, and our proper subset is violated. Do we get that? So good. Here's a trap. The empty set is not a proper subset of itself. We can only use this sign for it, but we can't use the proper sign for it. Are we together? All right, let's check your understanding with a quick true or false exercise. So we have 1, 2, pairing it with 1, 2, 3, comparing. We want to see, is this a proper subset or not? So first, we begin by checking 1 here, 2, 2. So let's call this A, right? Then call this B. So A is indeed a subset of B? Yes. But is it a proper subset, we have to check. Proper subset implies what? A must not equal B. So how many members here? 2. How many members here? 3. They are not equal. Therefore, this is true. It is indeed what? A proper subset. What about 1, 2, 3 and 1, 2, 3? Are they proper subsets? First, let's check. 1, 1, 2, 2, 3, 3. All the elements here can be found here. So they are subsets. But is it a proper subset? Because here we can see that A equal B. And that's not what proper subsets are about. Proper says they must not equal. So here, false. What we should rather use is the equal sign. Here we go. I'm sure someone just said So here we go. 1, 2, 3. Then we see what 1, 2, 3. Practically the same as this. So it's going to pass the check test. Yeah, so vibe check passed. Then we can see that the equality sign has been introduced here. So they are indeed equal. 3 elements here, 3 elements here. And therefore, this is true. And the last one, let's do it together. Let's check. 1, 1. We have 5. There's no 5 here. Don't tell me you add 2 and 3 to make up the 5. No, there's no 5 here. So this is not what? This is not an improper subset. It is not a subset at all. So we use this instead. Let's check our answers real quick. So we see that, right? Everything is accurate. So 1, 2 is indeed a proper subset of 1, 2, 3. Strictly inside it. B has extra. Here, 1, 2, 3, and 1, they are equal. So we have to make sure that the equal bar comes underneath. And that is what happened here. That's why this holds. But for this, we see 5 is not a member of 1, 2, 3. So 1, 5 then is not a subset of 1, 2, 3. Good. Now let's apply all of this in a worked example. We are going to do it together. So given A equals AB, B equals ABCD, we are going to determine whether A is a subset of B and whether A is a proper subset of B. First, let's check. A, B, B. Great. So all the elements in A can be found in B, which means A is a subset of B. Check. Is A a proper subset of B? We know proper implies what? A must not equal B. So let's check. A, what's the cardinality? 2 elements. B has 4 elements. B has extra. And since they are not equal, it implies that what? A is what? Indeed a proper subset of B. Let's check that right here. So we see A equals what? A, AB, B, A, B, C, D. The element A can be found in B. Check. Element B can be found in B. Check. Subset conclusion, indeed A is a subset of B. Then the proper, we have to make sure that they are not equal. A is not equal to B. A has 2 elements, B has 4, and due to that they are not equal. Ergo, A is indeed a proper subset of B. Does that make sense? All right, let's solve another example together. So here we have C, 1, 2, 3, D, 1, 2, 3. Let's do our checks. 1, 1, great. 2, 2, great. 3, 3. Wow. So we can see that C and D are equal, right? First, they've passed the check. Then C, we can confirm that is what? A subset of D. But is it a proper subset? We can see that there are 3 elements here, there are 3 elements here. So it means C equals D. And for that, it can't be what? Can't be proper, because that proper rule says that C cannot equal D. Okay? So C proper set, no, that's false. Right, we see that all the elements appear in there exactly. Then we realize that we can draw that conclusion safe and sound that C is indeed a subset of D. But for proper subsets, we have to make sure that what C is not equal to D. In this case, they are equal, and because they are equal, we can say that what? Exactly. We can say that C is a proper subset of D. Is that clear? Cool. Now, let's look at the third example. So we have E equals 159 F equals 1, 2, 3, 4, 5. Is E a subset of F? We're going to give our full reasoning here. Let's do the check together. So we see 1, yep, 1. 5, yep, 5. 9, no, we can't find 9 here. So because we can't find 9 here, it means what? E is not a subset of what? F. Because we can't find what? Not all the elements in E are contained in F. And for that reason, E is not a subset of what? F. We checked 1 and 5, they passed the check. 9 failed. And because of that failure, E is not a subset of F. Are we together? Is that clear? Great. So let's do this 4-part concept check. Right, so straightforward. Is the empty set a subset of 2, 4, 6? Yeah, you know this is the subset. It also means improper subset. But here we are looking, is the null set a subset of 2, 4, 6? Yes, because we said what? It's a subset of every what? Every set. I can't fail the check, so it's a subset of every set. So true. Then B. We are looking at the null set being a what? Let's indicate that a 2, 4, 6 here. So yeah, true. Then here, the null set being what? A proper subset of 2, 4, 6. We are going to check if this is true. Good. So proper means that what? They must not be equal. Cardinality for null set 0. Cardinality here 3. Those are not equal. So it is indeed what? A proper subset. The third one. Is the empty set a proper subset of itself? Proper means that the two sets must not be equal. But this here, 0 elements. This here, 0 elements. They are equal. And because they are equal, we can't say what? Not proper. We can't say that they are proper sets. It's a proper subset. No. Then D. We are explaining why the empty set is always a subset. Yes, so there is nothing in there to violate the rule. It doesn't have any element in there to violate the rule. Do we get that? So for that reason, it is what? Always a subset of every other set. Every other subset. Every other set you take, this is indeed a what? A subset of it. So this is the solution right here. So this is indeed a subset of 2, 4, 6. Yep. And it's also a proper subset. The equality doesn't hold. So 0 element here, 3 elements here. They are not equal, and therefore it is a what? A proper subset. Then the 2, 0 element, 0 element. That is equality. So we have to bring the equal sign here. If you take the equal sign away, the statement is false. Now we know why it is what? True. We have seen it so many times in this lesson already. Great. So let's look at how, it applies in the real world. It's because subsets are everywhere. Even numbers sit inside what? Natural numbers. African countries, they sit inside all world countries. Math students sit inside all students at a school. Red fruits sit inside all fruit. So every member of the smaller group belongs to the larger group. That is a subset relationship. You're already surrounded by set theory every day. All right. So 4 rules to lock in. 1. Subset A is an improper subset of B. That means every element of A is in B. And here equality is allowed. For 2, A is a proper subset of B. Every element of A is in B, and A is not equal to B. Then for 3, not a subset means that what? A is not a subset of B. That means that at least one element of A is missing in B. Then 4, the empty set is a subset of every set, proper subset of any non-empty set, but not a proper subset of itself.